Hello, welcome to Mr. Brown's second flipped classroom of the year. It's Introduction to Energy, and it's PS6, A, Potential and Kinetic Energy, and we're going to talk about forms of energy. So the big idea here is there are different forms of energy, and energy can be transformed from one form to another. So the essential question on your Cornell notes is going to be, what is energy? So write anything that's in red, and that's what gets on your Cornell notes. The other writing here is something we're going to be doing when you come in. We're going to be working in groups, and you're going to be thinking about what the scientific definition of energy is, and we're going to do a little tennis ball demo. We're also going to do a quick bungee jumping lab, so this is a little preview. In the lab, you're going to be dropping a mass attached to an elastic cord, and you're going to absorb how energy can change forms. How does it go from kinetic to potential, and then back up to kinetic. So for your Cornell notes, the first section, the first question you want to think about is, what are two types of energy? Remember, whatever's in the red, you write down. So energy is the ability to cause change and do work. Okay? So anytime you do something, you have energy being exhibited. Okay? So whether you pick up your pencil, you're writing, even just breathing, energy is being used when you do something. We're going to talk a little bit more about work later on in the year. So it can take many different forms, and there's two main forms. So at the bottom here, you have kinetic and potential energy. All energy can either be kinetic or it can be potential. And here's a couple of pictures and examples of potential energy, like squeezing down a spring, or the rock on top of a cliff, kind of like a Wile E. Coyote moment. Okay? And there's another one with the ball. Potential energy, it's up, and as it falls, it turns into kinetic energy. Okay? So real quick, some more definitions. Kinetic energy is the energy of an object due to its motion. Okay? Now, all moving objects have that kinetic energy. Kinetic energy depends on two things, the mass, okay, and the speed. If I increase the mass, it has more potential energy, or more kinetic energy, pardon me. If I increase the speed, it also has more kinetic energy. So think of your car. If your car goes faster, it has more kinetic energy. If you went from a car to a truck and is moving on the road, it has more kinetic energy. Okay. The other one is potential energy. And this is energy that is due to its position, whether it's chemical composition or its condition. All right. So the really easy one you can think of is gravitational potential energy. And potential energy, gravitational potential energy, can increase as you get higher, okay? Or you can have more mass. So think of your book. If your book's on your desk, right, it took energy to put on top there, so that's why it's potential energy. It's stored energy. Right? If it's a bigger book, it's going to have more potential energy because it took more energy to lift it up on your desk. If I take that book and put it on top of my cabinet, it's going to have even more gravitational potential energy because it took more energy to lift up. Here's a really easy example, and this is a roller coaster example. So everybody likes to go to Busch Gardens or to Hershey Park, and if you go ride a roller coaster, the chain pulling up is taking all the mass of the people in the cars and it's pulling you up, and you're gaining potential energy. It's storing the energy until you get to the very, very top. And once you get to the top and you start cresting over the hill and you start going down, that potential energy changes to kinetic energy. And then at the bottom of the hill is the greatest kinetic energy, and then you go back up to the top and get more potential energy. Our tennis ball demo we're going to do shows a very similar thing, a pendulum. Okay? If you lift the ball up, that's the highest point of the swing would be the most potential energy, the maximum gravitational potential energy, because gravity is pulling it down. As it swings to the bottom, okay, and right at the bottom, that moment it's at the bottom is the most maximum kinetic energy. And then it goes back up and gains more potential energy. Okay. So continuing with two types of energy. So a change in the condition of an object can affect its potential energy. So a good example would be rubber bands. Everybody used to like to stretch those rubber bands out and let them fly, right? So stretching a rubber band can increase its potential energy. The other way is chemical potential energy can depend on what it's made out of. A piece of paper actually has potential energy because it's you can burn it. So if you light it on fire, you can burn it and it releases energy. It's all stored in the bonds. Gasoline, oil, all those things have chemical potential energy. So can something have potential and kinetic energy at the same time? Well, yes, it can. So an object can have both. the potential and the kinetic energy at the same time. A great example would be a skater on like a skate park. So I think Leesburg has a skate park. And if you ever gone down there, you can imagine that example. A skater has kinetic energy as he's moving down the ramp and potential energy due to his position on the ramp. So if you're halfway down the ramp and you're moving, so you still have potential energy, but you're also, if you're moving, you have your kinetic energy. And we're going to show a quick video of that when you come back. Right. Our lab you're going to do after your notes, we review your notes, is spool racer lab. So you and your group are going to build and investigate a spool racer and analyze how it turns potential energy into kinetic energy. I hope you enjoyed this. Please write your summary at the end of the Cornell notes, and we will continue the Cornell notes next class with the forms of energy.